Today's lesson is on logarithmic functions, and these are very instrumental in solving exponential functions because they are actually the inverse of exponential functions. So we need to understand what a logarithm is. So the first thing to understand is that the common log is just denoted with a base 10. And on your calculator, you can find that log on your calculator. It literally says log, and that is by right above the ln key that we used earlier for e. So it's right by 7. Now what log basically means then is this is actually, and you read this, oops, sorry about that. You read this log base 10 of x equals y, or y equals log x. Everybody knows that log means 10. So to convert it to exponential, right there, you would take the base, which is 10, of the logarithm. The answer to a log is always an exponent, so 10 to the y would equal x. That's how we convert logarithms to exponential and exponential to logarithmic. So in other words, then, we can solve these. We know that the common log has a base 10, so this is simply 10 squared equals 100. Base, exponent, answer. That's usually what I say to myself. So base, exponent, answer. Now I know you're wondering, how is 10 to the negative 2.01? I don't get that. Well, how do you make negative 2 positive? We did this the other day. Well, that's 1 over 10 squared then, right? Well, that's 1 over 100. Well, 1 over 100 is 0.01. And then finally, C would be 10 to the, 10 to the 1.477 equals 30. And you can put that on your calculator and see if that indeed is true. And it is. Okay? Pretty cool stuff. Base. Now this explains it a little better. Not all logarithms have to have a base of a, or of 10. They can have a base of 2, or 4, or 5, or 50. It doesn't matter. But a logarithmic base that's not 10 still uses the same idea. It is the inverse of the exponential. So if I said that we had y equals log base a of x, I can convert that to a to the y equals x, because that is the relationship between logarithms and exponentials. So what I usually say is base is a here, exponent is always y, and then the answer I say is usually this. I don't know what's going on with my pen here. This is whacking out here. I don't know what's going on. Now I can't even erase it. Okay, so no big deal. So then here's our base, here's our exponent, and here's our answer. Base, exponent, answer. The log base a of the answer, or of this answer, is our exponent. So our exponents are always the answers to logarithms. So here's an easy example to illustrate that. Log base 3 of 81 equals 4. That means base, exponent, answer. 3 to the 4th is 81. And that is true. 16 to the 3/4 equals 8. And that is true, right? Well, is it? Well, I can break this up into 16 to the 4th to the 3rd. Well, 16 to the 1/4 is actually the 4th root of 16, which is 2. So 2 cubed is 8, guys. Haha, nice. So it does work. Now, let's write the exponentials, into logarithms, logarithmic. Well, our base is 8. Therefore, the base of our log is going to be 8. So we have log base 8 of 64 is 2. Remember, the answer to a logarithm is always an exponent. This is always the exponent. Always, always, always. And this is always the base of our exponential. So this would be log base 10, but we don't have to put 10 there. Of 0.001 is negative 3. Because 10 to the negative 3 equals 0.001. So how about this weird one? Well, it'd be log base u of w equals v. Why? Because v is our exponent. U is our base. So this is exponential. This is logarithmic. Pretty cool stuff. And very useful. And we'll get to why we need it as we go through this. Now, the natural log means we have the natural number. Now, I don't know why we don't say NL. Well, I do know why, because it's a logarithm. So it's really saying logarithm of the natural number. But instead of writing log base E, we just use that notation because it's much quicker. It's just ln. And I always write it like that. And I always write it in cursive, and so it goes fast. Some people write this, but then it looks like one N. So this is why I do that. Okay? So that means then that y equals ln of x, this is e. So e to the y equals x. Base, here's our base, here's our exponent, here's our answer. Base, exponent, answer. So how does this work with e? Well, here's e. So e cubed equals y. E to the v equals 0.01. Pretty slick, huh? Okay. Now, write these the other way. Write these in exponential form or logarithmic form. They're already in exponential form. So remember, the answer is the exponent. So this would be the natural log of 1.45 equals x. The natural log of 54.60 equals 4. And you could test that on your calculator. Take ln of 54.6. See if you get 4. You'll get like 3.9 repeating, probably. Okay? And if you wanted to find x here, there it is. Natural log of 1.45 would give you x. Now here's some properties of logarithms. Log base a of 1 equals 0, meaning any base, log of any base of 1 equals 0, because a to the 0 is 1. Now that means anything can be a. So the log of 1 is always 0. Now, anytime I have log 8 of 8, it's going to give you 1. Because 8 to the first is 8. So anytime these two numbers are the same, it's 1. Now, what's this inverse property? All right. Log base a of a to the x is always x. Because remember, this right here is 1. We just proved that right there. And now this little exponentially then, if I wrote this exponentially, then a to the log base a of x is x, because those two cancel out, basically, because they have the same bases. Now that also works with e's, so it's the same. They're exactly the same. We're just using natural log. The other one is the one-to-one property, which is if log base a of x equals log base a of y, then x has to equal y. Well, that makes perfect sense. So if the natural log of x equals the natural log of y, then x equals y. Now, we're going to use the properties of logarithms to solve these. Okay? Well, I see a log base 2 and a log base 2. So x equals 3. Easy. Well, here we go. Log base 4 of 4. Well, that has to be 1. Log base 5 of 5 to the x has to be x. 6 to the log base 6 of 20 has to be 20, because these cancel out, basically. Remember, this is an e, right? So the natural log of e to the negative 2 is just negative 2. What is square root of b? B to the half, right? Remember, the answer to a logarithm is an exponent. So we don't want to mess with this symbol. We want to convert it to exponents. So it's 1/2. Now we can also graph these things. And if you would take your calculator and go to y equals, and just put in natural log of x plus 3, and hit zoom 6, and look at your graph. You will notice now it's a little bit different than what we're used to. It actually then has a vertical asymptote, and it does something like this, right? Well, that means, see, we can't take the log of a negative number. So if I put negative 3 in, it's 0. Well, I can't take the log or natural log of 0 either. It doesn't exist. So it always, the logarithm, you have to have a positive number here. So x plus 3 is greater than 0 is how you find the domain. So x is greater than negative 3 is our domain. So negative 3 to infinity. And it really makes perfect sense because this number cannot be 0, cannot be negative. So you just set it greater than or equal to 0. So here's x plus 2. Okay, what's the domain? Well, x plus 2 has got to be greater than 0. So x has got to be greater than negative 2. And that's what that says right there, correct? So negative 2 to infinity. Now the range is negative infinity to infinity. Now what's our vertical asymptote? It looks to me like it is x equal negative 2. Now notice, remember inverses, the domain of f is equal to the range, of f inverse, and vice versa. Remember that from a long time ago? Well, think about it. Exponentials and logarithms are inverses. So what was the domain of an exponential? Ha-ha. It was the negative infinity to infinity. So a logarithm's range is always going to be negative infinity to infinity. Okay? Now this one says log base 4, negative log base 4 of x minus 3. Well, on the newer calculators, you can actually do this. And I haven't yet taken the time to find it. I can't remember. It really does not matter because, here we go. It's just log base. So it's under math. So it's just negative log base 4 of x minus 3, and then you can graph it. If you have an old calculator, I have to show you the change of base formula, which we will get to next time. So it's really no big deal because I graphed it right here. So notice then that the range has got to be again, or the domain, has got to be bigger than 3. So this is going to be 3 to infinity, but now the range is still negative infinity to infinity. Then the vertical asymptote would be x equals positive 3. Now, how do we use this to solve an equation? Well, think about it. I don't have any idea how to do A, how to find x, unless we will be able to convert it. Oh, look at that. Base, exponent, answer. Convert it to exponential. What do you know? 9 equals 4x minus 7. Add 7. Hey, x is 4. See if that works. 4 times 4 is 16. 16's minus 7 is 9. Log base 3 of 9 is 2. Is 3 squared 9? Yep. Okay, let's look at this one. X squared equals 64. Hey, x is 8. Now remember, our base cannot be negative, so the only answer there is 8. So log base 8 of 64 is 2. So 8 squared is 64. Makes perfect sense. Now, let's go the other way, solving an exponential with e. Well, here's the problem. There's no way I can do e to the 3x equals 10. But what if we change this to logarithm? And since it's e, it's a natural logarithm. So the natural log of 10 equals 3x. Right? Because your exponent is always your answer. Well, I'm going to divide by 3, so x is the natural log of 10 divided by 3. Now, I have no idea what that is. You can calculate it. It's approximately 0.768. But you know, this is the exact answer, so we could just leave it like that. Same way with this one. Natural log of 4x minus 1. Nope, that's not right, is it? The natural log of 9 equals 4x minus 1. Because the exponent's always the answer, right? So I would add 1 and divide by 4. So this would be our exact answer. Now again, you could put it in your calculator, but I would prefer just exact answers. It's just a little easier. Okay, now your assignment is in the book assignment, and I believe it begins, it's chapter 5 on logarithmic functions, and it's 5.1. It begins on page, I gotta get it here while I look, give me a second. Page 193. And again, this is on your assignment in your modules. 1 through 17, then 19 through 33 odd. Only do the odds, 19 through 33. 39 through 44. 53. And 57 through 65 odd. It's a lot of fun. I think you'll enjoy